Let's have a look at this then, this section of notes. Here's the sine function. If you draw the unit circle and you draw a triangle here, sine will be the opposite over the hypotenuse, and that's unit over 1. So it's the height, isn't it? It's the y-coordinate of p. So as the angle changes from 0 round to 90, round to 180, round to 270, round to 360, all the heights correspond to the angle will give the value of the sine function. So at 0, if x were 0, the height of that coordinate would be there, which would be 0. When it moves around to 90, the height is 1, isn't it? Because it's on the unit circle. Then when the angle comes around to 180, it's back at 0. Then when it moves around to 270, it's down to -1. And then when it comes around again here, the height is back to 0. And then if it goes around again to 450, it's back up at 1, isn't it? So from that you can see these are the heights. It goes down to 0, negative heights down to -1, back up to 0 from the negatives, then back up to 1, and then back down to 0 at 0. And that's the sine curve. There it is there. Now the cosine was the unit circle, it was the x-coordinate. So if we start from 0, the x-coordinate would be 1. Then if we go around to 90, the distance of the x-coordinate is 0 at 90, isn't it, when the angle's 90? Then 180, it was -1. And then 270 is 0 again. The x-coordinate would be 0. And then at 360, it's back to 1, isn't it? Then if it carries on to 450, it's back to 0. The x-coordinate would be 0 here, wouldn't it? Yeah, that's it. So that's the cosine function. There it is there. All the distances of the x-coordinate as the angle varies. And there they are mapped out there in terms of a sketch. Good. So that's, apologies for the quality of the sketches because this is a digital pen. Now the tan function is just the sine over cosine. So if you did 1 over 0, it shoots off to infinity here, because 1 over 0 would shoot off to infinity. So it's going to go way past 1, the tan function. So we can get rid of these 1s and -1s because it just shoots up massively. So I'll just get rid of them. But what we can see is if we look at the sine over cosine, it was 1 over 0. But then this number gets smaller. It's 0 over 1 here. So that would be a point there for the tan. 0 over 1 is 0. And then this over that, it's actually the same at 45. Because this value will be the same as that value at 45. So at 45, it's the value 1. But then this gets bigger, the top value, and this gets smaller, so it shoots off to infinity. So it basically looks like this, the tan function. There. And then on the other side, you see, it's still going to be 1 here, but there's going to be just 0 and small negative, so it flips it to -infinity. So it comes up from here. And if you look at 180, where's it go at 180? It's 0 over -1 is still 0. But it's coming up from the negative side, so it comes up here, like so. So it shoots off there, goes down there. And then 180, when it goes to 180, what about 270? Here again, let's draw in the asymptote. Because at 270, here, again, it's, what is it? Sine is -1 over cosine 0, so it's -infinity at 270. Yeah, but it's also just one side it's infinity and the other side it's -infinity. So yeah, and then it's the same down here. And at 360, let's just put the 360, I reckon there'll be 0 there. Sine over cosine at 360 is 0 over 1 is 0. So that's the curve. You can try and sketch it if you want, and look at more points. I'm not going to spend too long, on the tangent, but I am going to sketch it in just briefly. I specified a few points just out of interest, and you can type in a few values just to get the tan function. But it's the sine over the cosine. So these heights, divided by these heights. When there's 0, it shoots off to infinity, either positive or negative either side. Positive or negative. Positive or negative either side. So that's why they shoot up to infinity and minus infinity either side of those values. Okay, that's enough about sine, cos and tans then. We're going to do little sketches, so I'm going to use these graphs now to oversketch. The first one that we're asked to sketch is y equals 1 plus cos x. So here's the cosine function. So instead of it being 1, it would be just add 1 to everything. So move everything up by 1. So I'm just going to sketch it here. So that comes up by 1. This comes up by 1. This comes up by 1. And this comes up by 1. So I hope you can see that it would be not difficult. Once you've sketched the cosine, it wouldn't be that difficult a thing to sketch that curve there. Okay, that's y equals 1 plus cos then. Cosine of x. Let's look at the next example. Y equals 2 sine x now. 2 lots of sine x. So the 1 plus cos just shifted everything up by 1, but this will double every y value, won't it? So 2 lots of 0 is 0. 2 lots of 1 is 2. 2 lots of 0 is 0. 2 lots of minus 1 is minus 2. And 2 lots of 0 is 0. And 2 lots of 1 is 2. So can you see you double the heights? It stretches it out. There we go. And that would be that curve there then. We've doubled the height, you've stretched it vertically by a factor of 2, haven't we? So that's y equals 2 sine x then done. So that's that curve done. Now let's go back and do the next one. Okay. Y equals cos x minus 45. Cosine bracket x minus 45 degrees. What happens here then? Okay, we've got a cosine function. So if we put 90 in as our x value, right, we get cos 45. So if we put 135 in, that would be 90, wouldn't it? So the 13 value, this value, is the cos 90 height, isn't it? So that point moves across to there. And if we put in, say I put in 225, minus 45 equals 180. Cos 180 is this value here. So at 225, which is here, the value is, the cos of 180 is down there. See it? Let's try another one, so that we're just starting to get happy. Because try a few values. Try 315. So I'm just adding 45 degrees. If I try 315, take 45, I'll get 270. 315 is the input for the x value. The output is cosine of 270, which is here. So can you see that point is literally shifted forward 45 in a sense, isn't it? If I try 405 now, 405 minus 45, I'll get cos 360. So at input 405, I get the value here. 1. There. There's the input, there's the output. So can you see what's happened? All these points, it's as though it's just shifted it forward. So cos x minus 45 shifts the curve forward by 45 degrees along the x-axis. I hope you can see that. And that's the curve. So that shifted it forward 45 degrees. So you can overlay it. Use the cosine x to overlay the cos x minus 45, and that's how you do it in practice. So that's that one. You might want to run through that a few times so you're content with it. Do the input-output sort of approach, and it's not too bad to see what's what actually. Here we go. Let's try the next one now. On the graph, the next one is y equals sine 2x. Now we've already done 2 sine x, which is a totally different beast. So we don't need that, stretched it upwards. But what happens here? Let's have a look at sine 2x. We'll use the graph of sine x to overlay it. So when x is 45, see it? 45, which is here, input. is sine 90, isn't it? Which is that output there at sine 90. And when x is, say, 90, so you input 90, and you get the value at 290 is 180, that value there outputted the height. So the input is 90, the output is 0. Input output. So it's as though that squashed up to 45, that squashed up to 90. Let's try the next one. Let's try the 270. So if I try 135 input, which is here, okay, 135 is a 270, and that value, cos sine 270 is minus 1. So the input is 135, the output will be minus 1. So that moves there. So I hope you can see it squashed it up by a factor of 2, isn't it? Because that's half. This should be 180. And this should be 225. So can you see how it squashed the curve up by a factor of 2? There we go. Concertinaed it up by a factor of 2. So it's going up and down twice as quickly now instead of gently going up and down. It's going vum, vum, vum. Sound effects are come for free. Okay, so that's that one. Then that was sine 2x. Oh, let's just let's just get rid of the curve. So that was sine 2x then, wasn't it? Now let's see what else we've got to do. Couple more, I think. Next one. Y equals, ooh, this is nasty. 1.5 cosine x plus 180 degrees. So we'll do this in two stages. The first stage is to draw the cos x 180, and then we'll do the different color for the 1.5. So I'm just going to concentrate on cos x plus 180 first and forget about this 1.5. So cos x plus 180, well, if I got 0, input 0, I get cos 180. So like that point is there. So it's like it moved back, didn't it? Remember the minus moved it forward 45, the plus moves it back 180, it looks like to me. If I do the, so if I did minus 90 here, so at minus 90, which is here, I get cos of 90, which is 0. So that will move back there. And then we do move that one back there. What about the 270? If we put x is 90 in, cos 90 plus 180 is 270. Cos 270 is 0. So that was at 90. So that point there effectively is shifted back there, so to speak. So can you see with the 3 points we've done so far, that one went back there, that one went back there, and that one went back there. So we're going backwards now. You can see the pattern emerging. Back 180. Back 180. So the next one should be here, shouldn't it? And the next one should be here, just carrying on the cosine curve, because it is the cosine curve. So there's the curve. So I'm going to do it in yellow before we do the 1.5. So there's the first curve. And this is just, we've ignored that. We've drawn that one. Now what we'll do is we'll do y equals 1.5 cosine x plus 180 degrees. Now we scale these up by a factor of 1.5 times these values, don't we? So instead of 1, it goes up to 1 times 1.5. 0 times 1.5 is still there. I'm drawing the, oh hang on, no, I'm not drawing that. I'm drawing the yellow. It's the yellow one I want to draw by 1.5. So that one's there, 1.5. This one is 0. This one is 1.5. This one is 0. This one is 1.5. Can you see how it stretched it up? So it comes down, back, up, back, down, back. There we go. And that's the green curve there. Apologies for the poorness of sketch, because it's a digital pen. I think that'll conclude for now. There's one or two more examples, one more example in the notes, but I'll leave that off for now. Might come back to it in due course in a question.